Welcome to the webinar RO series UO S7KR. So today we will have a look on a new controller for our AR systems. We'll have a look shortly on controllers for the reverse osmosis units and then on the reverse osmosis operation with the PLC, the new RO series UO S7KR, and we will do a short comparison of the OPEX of a UO S7KR compared to a standard industrial UOD and D, and we'll have a short perspective afterwards. So the objectives of this video are to get to know the digital learning process and on the technical side, the basic understanding of control technology, introduction to reverse osmosis on unit operation with PLC, presentation of the revised RO series UO S7KR, and a comparison of operation costs. So let's start with the controllers. We'll have a look on the market overview, the setup of the PLC, the old controller RO5000 and our new controller Siemens S7 1200. And in the end, we'll do a short comparison. The microprocessor controller MPC was developed in the 1970s by Texas Instruments. Examples for microprocessors are computers, cars, refrigerators, cookers, calculators, measuring devices, etc. and used almost everywhere. It's suitable for large-scale production, so the only disadvantage is that we cannot adapt it later. And we have the Programmable logic controller, the PLC. It was developed also in the 1970s by Alan Bradley. The advantages are durability, safety, modularity, and flexibility for later adjustment. It's used in industry for complex applications. Major suppliers are Siemens, Rockwell, Schneider Electric, Mitsubishi Electric, and in Europe, Siemens dominates the market. So this is the main brand and also the brand we are using in our units. The setup of a PLC of Siemens looks like this. We have in the middle the CPU, the central processing unit. Then we have digital and analog input and output modules, IOs. And we have interface modules for example, Profinet connections. And we have the human-machine interface, the HMI, also so-called display. Our old microprocessor controller was the RO5000 for this series. It was in use since 2002 for two-staged RO units for the KR, so the concentrate staged ones, and also NDT, the permeate staged series. We have a 4-line graphic display. We navigate with the buttons that you can see here with the arrows. The display shows you the operation and fault messages and also an LED sign. We have no monitoring of flow and pressure. Data logging is possible, but it's limited to very basic things. And we cannot connect it to a central control system. New one, the PLC controller from Siemens, is in use since 2007, but only for special reverse osmosis units. From 2021, we started to have a new standard controller for the KR and UP series with the new design. We have two sizes of displays. It's either a 7-inch or 4-inch, and we navigate via the touchscreen, as you can see on the left side. And the 4-inch version also has arrow buttons. We have a display of alarm and warning signals. Displayed as a list for you guys that know already the Siemens version. It's exactly the same everywhere. And we have a complete monitoring of all measured data. Data logging and export is possible. And we can also connect it to the CCS. Now we see the next page of the panel. We always have the basic starting page, let's say, and then we have the flow diagram with the indication of measured data and status. So, for example, on the left side, we see the dosing pump with the 2 levels in green, also the limitron, our hardness control device that is displayed in green. So everything is fine here. In comparison, we can say that the old microprocessor controller has a let's say, more basic display, and the new one has a touchscreen, the dashboard, the PNID on it, alarm and warning list, so much more information displayed. The monitoring itself was for the controller only for conductivity, and we had a mechanical pressure switch. With the new PLC controller, we monitor all sensors like flows, pressures, electrical conductivity, and temperature. The inputs and outputs for the old controller were fixed and not extendable. With the new one, we have many digital and analog inputs, and we can also extend those and add additional cards. Then we have the universal in and outputs. Like you see, again, for the RO5000, we have fixed inputs and outputs, and for the new PLCs, we have doubled the in and universal in and outputs, and we can also extend those. Interfaces for the old controller were not existing. For the new controller, we have Profinet, Modbus, BACnet, also access via Smart Server, and remote access is possible. So the operation with the PLC. First, we will look shortly on the handling, the settings we are having in the new series, how we operate the system, and also the data. As mentioned before, the new controller has, again, 4 arrow and 5 symbol buttons. The symbol buttons are new, the arrows were present before, but not in the touchscreen. So the symbol buttons are for home, settings, faults, login, data, date, and time. We will look on this later. So we have invented a new color chart. We are using dark green colors as input fields, light green or gray as clickable buttons, and the blue frame for display of the data, and red, orange, and yellow for faults and warnings. So now let's have a look on the symbols in detail. The home button that you see on the left side is used for the dashboard and the PNID, the pipings and instruments diagram, but only for the 7-inch version. The smaller 4-inch version doesn't have the PNID. Then we have the settings button used for basic settings, the step times, universal in and outputs, the parameters, and also the language. And we have faults where we can see the current faults and also reset them. Next up, we have the login, the operator level for the user, cannot change settings, login manual. We have the technician, tech can change settings, also login in manual, and we have the administrator level, admin, access to the operating system and software, but this level is really only used for Herco employees. Then we have data where we see alarm messages, operation data, trend lines, and we can insert or remove the SD card. All right, last but not least, we have the system clock where we can set the time and the day. So now we jump right into the settings. See now the technician level, so we can change basic settings, step times, universal in and outputs, parameter settings. On the right side, we can see the flag with the English language, and we can change it from German to English or English to German. Others are available at extra charge. You can also set up your own phone number for the hotline, as you can see on the below side, below the software information. And in the administration level, we can set up the operating system, smart server system settings, IP address assignment for the display, screensavers. So you can also ask us for your own screensaver with, for example, your company logo. And you can also see the software version. When we go into the basic settings, we can select the type of the unit. As you can see on the top, it's a UOS 7 5000KR, so you can choose the unit size and it will automatically set up the correct settings for this unit. Then we can activate options like a dosing pump, permeate valves, analog sensors, limitron or KVP. For those of you who remember the old controller, it was quite, let's say, interesting to set this up, and now it's really easy. You just click the button, everything is set up. You don't have to set any parameters manually. Then, like before, we can set up the contact type of our level of the tank, permeate tank, and just say if it's a normally closed or normally open contact. As we go into the step times, we see we have every step: standby, start, rejection, production, displacement, and discontinuous rinsing. So this all remained exactly the same like with the old controller. The steps haven't changed at all. The only thing that is new here is the monitoring time. So this is just the same parameter as in the old controller, but with a different display. Let's say we have the starting time of 1 minute, and if after 1 minute and 30 the steps haven't reached their requirements, then we say there's a problem. And for rejection. All right, so what's new for the sensors? We have the digital inputs with 4 flow meters with a pulse output. So this is also something new with the Siemens PLC. We have pulse outputs and not an electrical signal. Also, furthermore, we have the motor protection switch for the pump like we had before. And we have 2 levels for the permeate tank, hot water protection for the limit run, and external stop if needed for external. Then we have analog outputs, 6 times pressure, permeate conductivity and temperature, conductivity of the concentrate stage. 3 optional inputs can be configured as level of the permeate tank, level tank kVp for the permeate flushing unit. So the flow meters are permeate, concentrate, recirculation, concentrate, and permeate of the KR stage. The pressures are feed of the pre-filter, feed of the pump, operation of the concentrate, and operation and concentrate pressures, operation of the KR stage, and concentrate pressure of the KR stage. And there's something new, as you can see. We have on those parameters, we have differential pressure values to tell us if we need to exchange the filter, for example, or if our reverse osmosis is blocking from scaling or else. So here we see again the parameter setting. This is an example now with a pressure sensor, PR05, that's the operation pressure. We can scale the sensor from 4 to 20 milliamps. So we can say 20 milliamps is equal to 25 bar. If, for example, you only have a 16 bar sensor in your car and you need to exchange the sensor, you can just set up here 16 bar and install the other one. Then we have a maximum value for the fault. In this case, it's 22 bar, just to tell our unit when to stop when we exceed our pressure. Then we have next the permeate flow as example. So as you can see here now, we don't have the 4 to 20 milliamp scaling. We have a K factor, and that's the K factor of the pulse sensor. Like in our digital controllers, we have a minimum warning and a maximum warning, just to tell our unit if we have exceeded our flow or we are really low flow. Next, we see universal input. So here we can configure what we want to do. We can set up the contact type, also the reaction, what should happen if our universal input is active, what delay we want to use, and then we can set up a name for the sensor. It's really important to choose when it should be active, otherwise it won't be active anyway. So on the right side, we can see examples of use. We can use it for a pre-empty signal or empty signal of dosing pumps for, say, base or else. And it's already assigned at the factory if the dosing pump is installed. All right, so then we have universal output. This is a bit easier. So then we just set up when we want our output to be active. If we want it to be active during when a certain valve is opened, or if a digital input is active, or during a specific step. All right, so this was the settings parts. Now we see the dashboard. So on the dashboard, we have decided to reduce all the parameters to the most, in our eyes, relevant parameters like permeate flow, operating pressure, conductivity of the permeate, temperature of the permeate, the active operation step, and also the on-off button. Then we have the flow diagram that we have already seen before, with all the pressures and operation states of the components. So green components are active, red components are at fault, and gray components are not active. On the second page, we see the flow diagram for our permeate tank and also the state of our universal digital in and outputs. If there's a problem with the unit, as I've mentioned before, then there will be some red indications. So we see, okay, we have a problem with the pump, the inlet valve, concentrate valves. So you directly see which component is causing you problems. If you're having faults, then this small pop-up window will pop up and will tell us which fault we are having. And to acknowledge this, we close the pop-up window and press the faults button. System starts up again if the fault is no longer pending. So this was the faults part. Now we come to data. We can see this is a bit separated into fault messages, operation messages, and we have statistics of the operation data. We can see historic data, see some trend lines, remove the SD card or insert the SD card if you want to read out the data from the SD card to your computer. The alarm list is red, orange, and yellow. Just red for the alarm, orange for warning, for acknowledged alarm, and orange for the warnings. So then we have the operating data. We have a counter for operating times for flows and maintenance data. We monitor the pump itself, how many operation hours we are having, dosing pump also. And then we count the permeate flow and the concentrate flow, so we know how much we have produced and how much wastewater we have produced. On the right side, we can see the maintenance time and period. So this is also something new. You can set up the maintenance after X days. So if you want to go there once per year, you set this up to 365. And then a pop-up window will pop up and tell the customer to do a maintenance. And you can reset the maintenance period itself with the reset button. On this slide, we see the trend curves and also some information about the data export on the SD card. We can just see if there's any trend, if the operation pressure is increasing, for example. And we have multiple preset screens. The data at ruler are displayed. It's set to 24 hours standard, but you can also zoom with the rectifier. The SD card saves analog data diagrams, default signals, and also the operating signals. So in summary, the main changes are we record all operating data. We can set limit values for fault warnings for pressures and everything and flows. We can export all data and we can also access external to the controller. Subsequent changes are possible, and benefits, we are more convenient and having a time-saving operation. The operational safety is higher due to automated monitoring. We can integrate the controller completely in a CCS system, and the remote access smart server can be implemented. So what's new for the RO series UO-S7KR? We have one new unit size. We have the two PLCs with display of 4-inch and 7-inch. Other changes, and then we will have a look on the interfaces. As you can see, we have one new series to cover the gap between 10,000 and 15,000 KR. So that's the new one, the 12,000 KR. And on the right side, you can see that the 7-inch, the bigger display, starts from a capacity of 4,000 liters per hour. Smaller ones do have 4-inch version, but can also be upgraded. So the 4-inch display that you see on top here are for sizes 3000 and 3500. We have arrow buttons as hardware buttons. We have a dashboard, but no flow diagram, PNID, and we have no socket for Profinet connection. The upgrade to the 7-inch version is possible, but at extra cost. The display with 7-inch size is for all reverse osmosis sizes from 4000. We have the arrow buttons on the touchscreen, dashboard and flow diagram, the PNID, and we have also the socket for the Profinet connection available. For the changes, we did some mechanical changes and the new instrumentation. On the mechanical side, we have a new concept for the inlet component group. We have no longer the requirement for compressed air for the control, and we have revised the options permeate recirculation and permeate flushing for those units. The instrumentation has changed. We have new flow sensors with a pulse output instead of rotor meters. We have new pressure sensors, we have analog sensors instead of manometers, and a new conductivity measurement with transmitter to 4 to 20 milliamps. So the interfaces that we offer are Profinet, Modbus RTU, Modbus TCP, and BACnet. Scope of delivery includes hardware and software as well as engineering costs, and transfer of 30 data points is included, or on demand at extra charge. So let's do a small OPEX comparison of UO AR compared to UO standard series. Then we will first have a look on general life cycle cost of the reverse osmosis. Then we will compare the recovery of a KR series and an ND series, and we do a short amortization calculation. So here we see the general life cycle costs. On the right side, we have chosen for an example, it's a UOD 10,000 ND unit with 75% recovery. We have 25% wastewater. We take the example with an operation of 12 hours per day and 350 days per year, and the operation with drinking water at a water cost of €1.50 per cubic meter and wastewater cost of €1.50 per cubic meter. Calculated with an electricity cost of €0.15 per kilowatt hour. Calculation is done over a period of 10 years. So on the left side, we see now the investment with 33,000, and we have the maintenance cost of 18,000, the energy cost of about 70,000, and the water cost in total of something about €1 million. So as we can see, the water cost is the most relevant one for us. So just a small repetition for those who don't already notice, our KR series increases the recovery from 75 to 87 to 90%. So what we are doing, we are using the concentrate of our normal reverse osmosis stage, and we go onto a second concentrate stage realized with a nanofiltration membrane and recirculate this produced permeate, let's call it, of the nano stage back in front to the pump, and so we can increase the recovery up to 90%. So now we see this all in numbers. On the left side again, the standard calculation that we have just seen, and on the right side, the same calculation with the life cycle cost with the KR series with the decreased wastewater. So as we can already see, the water cost has decreased by almost €300,000. So conclusion, the UO S7 KR reaches break-even after only 7 months compared to a UOD ND. So after 10 years life cycle cost of UO S7 KR, we are already at €255,000 lower. So more than 20% are saved. So as summary, you can say the plant operation with the PLC, the safe operation due to complete monitoring of the system. We have an intuitive and convenient operation via the touch panel. We can integrate it into a central control system, and UOS7 KR series has a higher recovery than our standard plants due to the KR stage. We reach up to 90%. We have high investment cost, but they are redeemed in few months only, and we have a future-proof water-saving process technology.
Upcoming, we have a new webinar on our new ultra pure water series UP S7 with also the new PLC controller. So many thanks for your attention and see you soon.